hope you already either read through my typed notes from 18.1a or watched my video of the notes. And it was long. It was 2 sections. Both of them were over 20 minutes long. Or maybe you chose to watch the slightly shorter version that Mrs. Franken did. The only problem with watching hers is you may not know exactly what steps are required. So I'm glad you're here so you can see what steps are required on this one. And if you think you totally understand it, you always need to skim through these to see if you've done them correctly, because I don't want you to turn them in wrong if I took the time to work them out for you. I'm going to do a few of these, mostly evens, but maybe an odd if it looks appealing to me. This one says, draw the indicated angle of rotation in standard position. And no matter what size angle they want you to draw, standard position means you start with a ray, let's call this your initial ray, on the positive side of the x-axis. There we go, and it doesn't matter. I'm probably not even going to do number 1, but I'm still going to draw it in. And then you can draw your angle from there. If they ask you to draw a positive angle, you're going to start here and go upward. If they ask you to draw a negative angle, you're going to start here and go downwards. These 2 problems ask me to find an angle that's coterminal to 130 degrees. That means I need to figure out where 130 degrees is, and I need to draw another one that's in the same place. Okay, I just squeezed a little circle with my degree measures in from the notes. And if I wanted to draw 138 degrees, I could look up here and I could say, well, there's 135. I don't want 135. I could think about going here, going almost not quite to that point. That's what I'm going to do over here. If I wanted a positive angle, let me just draw the 130 degrees over here so we can think about what 130 degrees looks like. 130 degrees would be right here. This is not an answer to the question. It's going to be right here. And it needs to go up because it's positive. If it went to the center, it would be 130 degrees. But I don't want to go to the center. I want to go just a little bit short of that center, right around there somewhere. If somebody asked you for a positive angle that's coterminal to 130 degrees, well, 130 degrees is positive, but I wouldn't say it was coterminal to 130 degrees. They're looking for something different from that. If I'm looking at number 2, because I'll leave number 1 to you, they want one that ends up in the same place but goes in the negative direction to get there. So I'm going down instead of up. And I need to, maybe I'll use some numbers to calculate where I'm going first. This is 130. And I want to turn it into a negative number, so I'm going to subtract 360 degrees. If I take 130 minus 360, I'm going to be at negative 230 degrees. So if I think about drawing this curve, this arc, negative 90, negative 180, if I went all the way up to here, I'd be at negative 270. That's definitely too far for me. So take it back a ways. And we already talked about the fact that it's going to be near the center. So if I've already drawn 180, I want 230. And I've already done 180 of that. The question is, how much do I have left to do? So if I do negative 230 with 180, I end up with 50 degrees in the negative direction. This is what I need, negative 230. This is what I already drew, the blue part up there. It's 180 degrees. I got to go another 50 degrees in the negative direction. If I went exactly to the center of that space, I'd be at 45 degrees. I need to be just barely past the center here. So I'm going to take it right around here somewhere, a little past the center. Put an arrow, and yes, I do insist on those arrows. You take your homework quiz, you forget those arrows, you're losing a half a point. That angle is in the same position as 130 degrees, but it went in the negative direction to get there. I could have done it differently. I could have said, I want to go to that space, but I think I'm going to go, 10, 15, 20, 100 times around, and then I could still end up at that place. And it would still be correct, but the one I did is the easiest version of that. Okay, let's look at another problem. I think those are the only two on this assignment where you have to draw the angles. We'll have more on the B assignment. I think we spent 4 days on 18.1. Okay, we have some problems here. They want me to find 2 positive coterminal angles and the nearest 2 negative coterminal angles. Let's do an odd and let's do 2 evens. We're going to do number 4, which gives me 420 degrees. And we're going to do number 6, which gives me 5 pi over 2. Then you've got an example that's in degrees and an example that's in radians. If you want to find something that's coterminal, you have to add and subtract a full circle. And a full circle in degrees is 360 degrees. In radians, I'm going to add and subtract 2 pi. But since we have a fraction, we'll have to match that denominator first. So I'm going to take 420 degrees. I'm going to make it bigger. Extra turn around the circle plus 360 degrees, which gives me 780 degrees. There is a positive angle that is coterminal to that. Take that. I'm going to add another 360 degrees. 780 plus 360 gives me 1,140 degrees. Okay. I also want some negative ones, so I'm going to say take 420 and subtract 360 degrees, which gives me 60 degrees. I was aiming for a negative, and I got a positive. It's still a good positive answer, but since they wanted us to find the nearest 2 negative and the nearest 2 positive, I would have to say that I think 780 and 60 are both nearer than 1140. I wouldn't mark it wrong if you used 1140, but somehow we still have to get a couple of negatives in there. So I'm going to go minus 360, which gives me negative 300 degrees. That's my first negative one. And minus 360 again to give me negative 760 degrees. Again, if you used this one for one of your positives, I wouldn't object to it. But you can't just say, I subtracted twice, I'm done. You have to make sure that you end up with at least 2 positives and at least 2 negatives. The other one I need to deal with is 5 pi over 2. This one is in radians, which means I'm going to have to add and subtract 2 pi. So I'm going to start out with saying 2 pi over 1. And I want it to have a common denominator here, so I'm going to have to make it equal something pi over 2. If I want this to turn into 2 on the bottom. Then I need to multiply the bottom by 2. And since I want to change the way it looks without changing its value, I have to multiply 2 over 2. So I'm really just multiplying by 1. So the top is 2 times 2 is 4 pi over 2. So I'm taking 5 pi over 2 and I am adding 4 pi over 2 to give me 9 pi over 2. Now if I stop and think for a minute, instead of having to do all that adding and subtracting and getting things I don't need, I'm going to stop and think about where exactly is 5 pi over 2. This is 0. This is also 2 pi. So this would be pi. If I'm splitting it in half, this would be pi over 2, and we'll get into more of that later. This would be 1 half, 2 halves, 3 halves, and 4 halves. It's really already more than a full circle. So I think that I could go back and say I already have a big enough positive. If I try and take my 5 pi over 2 and subtract 4 pi over 2, I will have another positive. But even without looking at a graph, since we really haven't done graphs with radians very much yet, just knowing that subtracting 4 pi over 2 would still leave it positive tells me there's my best 2 positive answers. I need some negatives as well. So I'm going to say 5 pi over 2 minus a full circle. This is my full circle because that is 2 pi. 4 pi over 2 reduces down to 2 pi. So 5 pi over 2 minus 4 pi over 2 gives me 1 pi over 2. I already did that one, didn't I? What if instead I do 5 pi over 2 plus 4 over 2 pi over 2 already done? How about take one of these that is already small, pi over 2, and subtract from there. In other words, instead of starting back at the beginning, we're continuing with this. This is 1 pi over 2 minus 4 pi over 2, negative 3 pi over 2. And continue from where I left off there, negative 3 pi over 2, subtract a full circle from there, so subtract 4 pi over 2, and get my final negative, which is negative 7 pi over 2. There we go. 2 positives, 2 negatives. They were created by starting with the original one and adding a full circle or subtracting a full circle until I got a reasonable selection of 2 positives and 2 negatives. Let's see what else we have in this assignment. Degrees to radians, radians to degrees. Remember that when we're going to use degrees to radians and radians to degrees, we know that 360 degrees is a full circle, 2 pi. So 180 degrees is just my pi. I'm going to take and use 180 over pi, or I'm going to use pi over 180 degrees. Depends on what I have and what I'm trying to get rid of. So I'm going to do a couple of these. Let's look at this one first. 2160. It has degrees in it. I don't want degrees. If it starts with degrees, I'm going to change it to radians. I'm going to take out that and put in the pi. So I want to get rid of degrees. I will put 180 degrees down on the bottom. I want to get a pi into that, so I'll put a pi up on top. Then I need to reduce. The degrees can go away. Forget the degrees. If they both end in 0, I always start with divide by 10, which is just cutting off the zeros. If one had 2 zeros and one had 1 0, I could still only cut off one of them. Then I'm trying to look at, is 216 divisible by 18? I just happen to know that 216 is 6 to the third power. So I can take this and say 6 goes in here 3, and 6 goes in here 36. If I didn't know that, I could take my calculator and just say 216 over 18 and see what the calculator tells me. It happens to be 12, but if I hadn't noticed it before, I could still deal with it by saying, and now 3 goes in there once and 3 goes in there 12 times. So I still have 12 on the top, I still have pi on the top. The bottom is 1 times 1 is just 1. So the answer for that is 12 pi. Now, 2,160 degrees has got to be a lot of times around the circle. So it makes sense that the final answer in radians is 12 pi. That's 2 pi each time around the circle, so that's actually 6 times around the circle. Let's do another one from here. Let me do a radian one. And why don't we just choose the negative one just to be fun, because we got to do a negative one. I know that the first time I did the answer key for this, I don't know if it was number 14 or if it was number 13. I know that I got so busy crossing things out that I forgot to ever put in my negative sign. And then I had to correct my answer later. So in this problem, I'm trying to get rid of the pi, so the pi goes on the bottom. I'm trying to get some degrees going on, so the degrees go up on top. And since I know I have a habit of leaving out that negative, getting lost in the middle of all the canceling, I'm going to take care of putting the negative over there first. Okay, drop out the pi's. If you're doing this one in your calculator, I recommend you just drop out the pi's before you even try to put anything in your calculator. Then I'm going to say 2 goes into an even number. 2 goes in there once. 2 goes into 18 9 times, so that's 90 times. All I have left on the bottom is 1. I know 9 times 7 is 63, so 90 times 7 should be 630. There's my 630 degrees. I think converting from degrees to radians to degrees is probably one of the easiest things you're going to do in this assignment. If I'm working over here, I'm not going to completely work any of the ones over here. I could say, I want to get rid of the degrees, put 180 degrees on the bottom, and throw the pi up on top. Work with that one. Make sure you make it negative. If I look at number 11, I want to make sure that I am getting rid of the pi. So I'm going to put my pi on the bottom and my 180 degrees up on top so the pi's can cancel and I get something in degrees. On number 9, the degrees are going to cancel. I'm going to get something with a pi in it. I don't know what. Okay. Those shouldn't be too bad. Let's look at the next page. If you listen to my notes, this is the one where I said, I'm not doing this problem for you in the homework. This is another example that's kind of like the one with the people running around the track. You've got an arc here, got an arc here. I know that if you listen to my notes, not Mrs. Rankin's notes, I really talked about that a lot. This is the formula from the notes that you're going to need. Look back to the notes, analyze what they did. You're going to figure out the measure of this arc using this formula, the measure of this arc using this formula, then you're going to subtract the two of those. I'm not doing that one for you. This one, though, I like this one. But I always feel the need to talk about it because there are people who just want to say multiple choice, multiple guess. I'll just guess. I don't want you to just guess. don't even want you to just punch numbers in your calculator and then circle the right answer. I want you to prove to me what you're doing. We're trying to figure out which of those work. And some of those are in radians and some of those are in degrees. And degrees, they always put the degree symbol on it. Radians, we generally don't bother to put the word radians on it. If it's written with a pi on it, we'll just assume it's in radians. It is possible to write in radian measure without pi in it, but we will just assume if the pi is in there, that's in radians. I think that it's probably easier for you to do the degrees than it is for you to do the radians. So if you wanted to do the degrees, I could just say, I don't know which one of those match. Add 360, see if it matches any of those. Add 360, see if it matches any of those. Add 360, see if it matches any of those, until you either match up with 2100, the biggest one there, or go past it without touching. If you match exactly by adding 360, or if you match exactly by subtracting 360, you can circle it. If you go past and you don't ever actually touch that number, that's the ones you would cross out. I'm going to do half this problem for you. I'm going to do the radian half. That means I want to know if it matches an angle of rotation of 300 degrees. Well, first thing I need to know is, what's 300 degrees in radians? So I'm going to say 300 degrees, changing to radians. I want to get rid of the degrees. 180 degrees down there, put the pi up here. Cross out the degrees. They both have a 0, so cross out one of the zeros. You can't cross out the other 0 on the 300, only one of them. And then I'm going to say what goes into both 18 and 300. And I say 6 goes in here 3, 6 goes in here 5. I get 5 pi over 3. That's the basic 300 degrees that I'm going to be using for my starting number. So 5 pi over 3. I'm going to look at all of these that have radians on them. If there's anything there that's bigger than 5 pi over 3, like E, then I'm going to start adding. I need to add 2 pi to that. 2 pi over 1. And I need to make it into something pi over 3. So times 3 times 3, 6 pi over 3. I hope that pretty soon you're good enough that you don't have to write that down every time. But I still want to see what you're adding and subtracting. So 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. So I'm looking over here, and the only positive one I have is 23 pi over 3. I'm not there yet. So I'm going to take 11 pi over 3, and I'm going to add to that another full circle. So now I have 17 pi over 3. Still not big enough to match that. So I'm going to take 17 pi over 3 plus another full circle. This is 2 pi, 6 pi over 3. And 17 plus 6 is 23 pi over 3. Yes, that's the one I was hoping for. The rest of the radian answers are smaller than 5 pi over 3. They're negatives. So I'm going to go back and start again. 5 pi over 3. And see if I can go in the negative direction and match up with those numbers. Minus 6 pi over 3 is negative 1 pi over 3. Yes, I have that one. There's another one that's even more negative. So let's start from where we left off. Negative 1 pi over 3 minus 6 pi over 3, which gives me negative 7 pi Yes, all the radian ones end up matching. And I think out of the 3 degree ones, at least one of the degree ones matches up. But you do what I did here, except you do it with degrees. You keep adding and adding until you get there, or maybe go past. If we had on this list something that said negative 4 pi over 3, if I had something here that said negative 4 pi over 3, I would have said 5 pi over 3? Nope. If I subtracted the first time and I went past it, I went negative 1 pi over 3, that was still good. But when I went past it by going to negative 7 pi over 3, then I would cross that out. That's going to happen somewhere among the degree problems. Okay, I think I did enough of those so that you'll know what I'm doing. Make sure that when you check your assignment, you mark the odds all right or wrong with your circles for correct and your X's for wrong. The evens, the ones that I worked out for you, must be fixed and made right. They should be circled because you should fix them and make them right. There are just a few evens that I didn't end up doing for you, so you won't know exactly. For instance, number 8 and number 12. If you try them, you'll just be underlining them because you don't know if they're correct. What else is here? We did 4 and 6 both. We did 2 both, so we did 2, 4, 6, 10, 14. There will only be 2 problems on the whole assignment where you don't know if they're right or wrong. Those are the ones that you circle. Those are the ones that instead of circling you have to underline because you just don't know. I refuse to give you every single answer because I know that you have to do a few on your own without necessarily knowing in advance if they're right or wrong. Okay, if you still have more questions, make sure you check into the Zoom meeting on Tuesday and Thursday morning so that you can ask me more questions. That's all for now.